Yes, today we are going to look this particular question. Evaluate the limit of the following function. We're given a function at the limit of x approaches 0, then there is a root of x plus 4, then minus a 2 over x. So the first thing that we normally, what comes in our mind, so we try to plug the value of x in that function. So when we try to plug the value of x in that function, automatically you are going to get a value like 0 over 0, which is undefined kind of a condition, or what we call undeterminate form of a function, so which is a 0, meaning the limit at that point does not exist. So we have to look for another alternative so that the limit of this function will be existing. So there is a root here, then there is a minus 2 over x. The best method that will help us to eliminate the use of a root is just to apply rationalization kind of a technique. That one will eliminate the use of a root. So let us work out it. As the limit as x approaches 0, we are saying the root of x plus a 4 and then minus a 2 over x. So we multiply by the conjugate of it, that is x plus 4 minus a 2, then over, there is a plus. When you multiply by conjugate, remember you are negating this sign that is inside here, that is a positive. The root of x plus a 4, then plus a 2. So bring it in together so that it will bring some logic. So the root of x plus 4 minus a 2, we multiply by the root of x plus 4 plus a 2 over x multiplied by the root of x plus 4 then plus a 2. I want you to recall this kind of an identity. When we say a square minus b square is the same as a plus b, that way, no? So recall this kind of that identity that we learn in trigonometric identities, mathematical identities. So a square minus b square is the same as a minus b, a plus b. So this function is this function. So want to bring it so that it becomes this form. So that is to say, as the limit of x approaches 0, that is to say I'm taking a function that is the value of a, this one will be the value of a, x plus 4, and then I'm squaring it, that is the value of ab, then minus b square, that is 2 square, over x, the root of x plus 4 plus 2. Instead of opening this one, open by this. So to save on your minimization of a space, you just do this way in a simpler kind of a manner. So when you open the bracket or you remove the root, so this square will go with this, you will be left with x plus 4, then this one, it is negative 4 over x, the root of x plus 4 plus 2. So this one will go with this. So left as the limit as x approaches 0, we are saying x over x, the root of x plus 4, and then plus a 2. So we are able to cancel the values of x. We left as the limit as x approaches 0, 1 over the root of x plus 4 over 2. So that is to say 1 over, when you introduce the value of a 0, by 0 plus 4, then plus a 2. That is to say 1 over 2 plus a 2. This one will give you 1 over 4. So we have used rationalization technique to find the limit of this. Although when we try to plug the value of x in that function, it will give us a 0 over 0, which means the limit of that function is undefined. But when you use rationalization technique, we arrive at the 1 over 4 as the limit of that function. So using the rationalization technique, this one is the simplest way of evaluating the limit. You will enjoy it. It is so interesting. Look at the steps that I have undergone to arrive to my answer. Just a few steps. You employ this kind of a rule and then you get your answer. Thank you for watching. Then don't forget to subscribe.